Okay, for the first problem, let's draw the free body diagram first. So here there's a wall. There is a spring here, K3. There's another spring here, K1. And under K3 there's a small block M1. Under M1 there's another spring, K2. And both K2 and K1 are connected to a large block, which is M2. Let's here, M2. Okay. According to the information in the problem, the displacement of M1 is x1. The displacement of M2 is x2. So the end of K3, the displacement of this end of K3 is also K1 because it's connected to M1. So it should be x1. And this end, the upper end of K2, the displacement of the upper end of K2 is also x1, and the lower end, the displacement of the lower end of K2 is x2 because it's connected to M2, and the displacement of this end of K1 is also x2. Okay, now next forces. There is a force on this end of K3. Let's say it's F3, and on K1 there's a F1 due to Newton's third law, force and counterforce. So there's the opposite F3 on M1, and there's the opposite F1 on M2. And for K2, let's see, there's force F2 here and here. So there's a force on the lower end of M1, F2, force and counterforce, and here on M2 also force and counterforce. So there's a F2 upwards on the left side of M2. Also there's a force Ft downwards on M2. Okay, now let's write the equation for each element. For the spring K3, F3 equals K3 times x1. And for spring K1, F1 equals K1 times x2. For the spring K2, F2 equals K2 times x2 minus x1. Okay, so for the smaller block M1, we can write the equation according to Newton's second law. Second law. M1 times x1 double dot equals f2 minus f3. F2 is positive because it's on the same direction with x1. Yes, and for the larger block M2 times x2 double dot equals ft minus f2 minus f1. Okay, so let's plug in f1, f2, and f3. For the first equation, m1 x1 double dot equals k2 x2 minus x1 minus k3 x1. For the second equation, m2 x2 double dot equals f of t minus k2 times x2 minus x1 minus k1 x2. Alright, so the first equation, 1 x1 double dot equals k2 x2 minus k2 x1 minus k3 x1. So we can move the right side of the equation to the left. We can get 1 x1 double dot minus k2 x2 plus k2 plus k3 times x1 equals 0. And for the second equation, m2 x2 double dot equals ft minus k2 x2 plus k2 x1 minus k1 x2. And then we can move this part to the left side of the equation. Then we can get 2 m2 times x2 double dot plus k2 x2 minus k2 x1 plus k1 x2 equals f of t. Then m times x2 double dot plus k1 plus k2 times x2 minus k2 times x1 equals f of t. And according to the information in the problem, we know that k1 equals k and k2 equals k3 equals 2k. So we can plug this into the equations here and here. So we got m1 x1 double dot minus 2k x2 plus 4k x1 equals 0. For the next equation, we got m2 x2 double dot plus 3k x2 minus 2k x1 equals f of t. Yeah, and So this is the final answer here. Perfect. Thank you.